GATE 2021 Metallurgy Question 52. At 25 degrees Celsius, iron corrodes in a deaerated acid of pH 3 with a corrosion current density of 4 microampere per centimeter square. The corrosion potential is the given data beta C, it is the Tafel slope, equal to 0.1 volt per decade of current density. Exchange current density of the hydrogen on iron surface 10 raised to power minus 9 ampere per centimeter square. Universal gas constant R is given to be 8.314 joule per mole per Kelvin. Faraday's constant value is 96500 coulomb per mole. Okay. So, looking at the given data, it is given the acid is having a pH value of 3. The corrosion current density is 4. I core is 4 into 10 raised to power minus 6 ampere per centimeter square. The pH value is 3. pH is nothing but minus log of concentration of hydrogen ions in the solution equal to 3. So concentration of hydrogen ions in the solution is nothing but 10 raised to power minus 3. Now, using the Nernst equation, we will find the reduction potential of hydrogen in iron. So, since iron is corroding, so and it is an acidic solution, hence the hydrogen ions are going to get reduced to hydrogen gas on the cathode. So reduction reaction will be 2H plus 2 electrons coming from the iron will liberate hydrogen gas. Okay. So applying Nernst equation on the equation, the reduction reaction, the reduction potential E will be nothing but the standard reduction potential of hydrogen minus RT NF ln 1 over since the constant is 2, so it will come to the power the concentration of hydrogen ions. We can also write it 2.303 RT or NF log in terms of log. These all are constant, so I can club them together and write this equation as 0.0591 upon N. N is the number of electrons taking part in the reduction reaction, log of what is the concentration of hydrogen ions? It is 10 raised to power minus 3. So square it will 10 raised to power minus 6. So number of electrons taking part is 2. So here we can write it as 2. Okay. Now the standard reduction potential of hydrogen is taken to be 0. Therefore, the reduction potential is going to be minus 0.177 volt. Okay. So I'm going to use this value again. Next slide. So the value that we determined is 0.1773 volt minus. Okay. Now we are required to find the value of E core we are required to find the value of corrosion potential, and what is given is the exchange current density is given. The exchange current density is given, that is I naught is given 10 raised to power minus 9 ampere per centimeter square, and the Tafel slope, the value of Tafel slope is given 0.1 volt per decade. Okay. So here the Tafel equation will come into play. Tafel equation is nothing but the approximation of Butler-Volmer equation when the overpotential magnitude is more than 0.1 volt. Okay. So this is a special case of Butler-Volmer equation. There are certain assumptions that we made in this Tafel equation. The first assumption, the main assumption is the concentration of ions at the electrode is assumed to be equal to the concentration in the bulk electrolyte. So hence the current can be expressed as a function of potentials only. Okay, and that potential we call it as activation over potential. Concentration gradient is not taken into consideration in Tafel equation. Okay. So according to Tafel equation, the activation over potential is nothing but beta C. Beta C is the Tafel slope log of I core upon I naught, where I naught is exchange current density and I core is corrosion current density. Okay. So using this, we will get 0.1 log of. Now here the corrosion current density is given to be 4 microampere per centimeter square. It can also be written as 4 into 10 raised to power minus 6 ampere per centimeter square. So 4 into 10 raised to power minus 6 upon the exchange current density is 10 raised to power minus 9, 10 raised to power minus 9 ampere per centimeter square. Okay. And it is treated as a negative expression. So it will give us a value, upon simplification we will get minus 0.36 volt. Now mind it, this Tafel slope is nothing but 2.303 RT upon alpha n. Okay. It is a function of different constants. T is absolute temperature, R is universal gas constant, alpha is the charge transfer coefficient, n is the number of electrons taking part in the reduction reaction, and F is the Faraday's constant. Right? So here we get the overpotential value. Overpotential is nothing but E core minus E equilibrium minus 0.36 volt. Now, E equilibrium we have determined as from the Nernst equation under equilibrium conditions. So corrosion potential is nothing but minus 0.36 plus minus 0.1773 volt. So upon solving we will get minus 0.5373 volt. So this is the value that we were looking for, the E core value. For If you want to know more about the Tafel equation and the Butler-Volmer equation and its derivation, you can look at the given NPTEL video reference, that is lecture 34 and 35 of corrosion part 1 by Professor Kalol Mondal from Department of Metallurgy and Material Science, IIT Kanpur.